Explain it like I'm five. Blockchain and cryptocurrency. So you guys have probably heard these terms, blockchain and cryptocurrency, already throughout the news and the media, and have somewhat of an understanding about it, and kind of like what they entail. You may have also heard the terms peer-to-peer network and decentralized ledger technology. The point of this video, what I'm trying to help you guys do is to formulate a better mental model of how these things work together, and understanding what they are from an individual standpoint, in terms of their mechanics and their purpose, but more importantly, how they work together to create something much greater. And so the way that I think is best for people to kind of wrap their minds around this is to think of these things as working together, um, to create something larger. And we'll call this a world computer. Now, this is not exactly a widely used term yet. It is used by some, but I think it's best to kind of think of these things as a larger unit that we'll call a world computer, for you to be able to kind of conceptualize what's going on. So what do I mean by world computer? A world computer is something that is publicly run and publicly accessible. It is run by the people. It is used and accessible by the people. It is decentralized. And this is the key term here. That's something else that you've probably heard a lot, in conjunction with the terms blockchain and cryptocurrency, is decentralized. And so what does decentralized really mean? Let's go into that real quickly. Decentralized can be best explained by thinking of its kind of counterpart, which is something that is centralized. The current way that the internet works, it is more or less a centralized system. And the best way to kind of think about that is that there's this big computer out there, not like your laptops or your desktops or your tablets or iPhones, but a big computer that is meant for doing one thing, and that is storing information. And we often recall this the cloud. And the way the cloud works is that everybody else's computer, that includes your desktop and your mobile phone and your tablets and things like that, they connect to that information. And when you go onto your applications, when you go onto your social media, what's going on is that you connect to the cloud that has all this information stored on it, and therefore you can access it. Now, in a decentralized kind of system, you don't have that middle computer, that centralized computer or the cloud. Instead, what you leverage is the aggregate or the connections of all of the computers together in order to store all that information. There is no central computer that has it. Instead, it exists among the network of computers connected to one another. And so that's a quick overview of what decentralized means. It basically means that you don't have a central entity that is storing or is in charge of this asset or this thing that everybody is accessing or using. All right, so back to defining a world computer. Publicly run, accessible, decentralized. And because it's decentralized, it is there irrepressible, meaning that you can't shut it down. It transcends government and regional control. It's not owned by anybody. And therefore, you can't have some sort of central entity shutting it down, and saying it can't operate anymore. It is therefore also immutable, meaning all the information that exists on it can't be erased. There's nobody there that has the power to just erase all of the information. However, it is trustless, or this actually kind of makes it trustless. Trustless is kind of a new word for a lot of people, and it first sounds kind of negative, like trustless, like there isn't any trust, but it's not perhaps the way that you think about that. And instead of meaning it doesn't have any trust, think of it like there is no need to worry about trust. Because it's decentralized, because it's irrepressible, because it's immutable, you don't have to worry about people messing with the numbers or messing with that information. You can always trust that it's going to have accurate information, and you can always trust that it's going to do the right thing in terms of how it handles information. The next thing is to think about is that it's going to be encrypted and highly secure. And finally, and this is another big important one, it is financially self-sufficient. And what I mean by that is if you have a world computer that is decentralized and therefore transcends government, regional, corporate control, who's paying for it? Who owns it? Well, it would have to be financially self-sufficient, meaning that it was able to support itself financially. It paid for its own existence. And we'll get into that momentarily as we explore an analogy that I have come up with to help people kind of understand the interworkings of all of this stuff. But first, I want to kind of talk about the trajectory of a world computer. Right now, we're seeing the advent of world computers. And I want everyone to kind of reflect back on a time where, like, we had the first computer, these big, clumsy, bulky machines that could really do very simple things, very simple calculations. Now, much like the first computers out there, the very first world computer can really only do one thing, and that is to keep track of a value. And that value is called Bitcoin. And so Bitcoin came along in about 2008, I believe, when a white paper was published titled Bitcoin, a peer-to-peer electronic cash system by a named Satoshi Nakamoto. No one really knows who this person is. Most likely it's they. It's probably a collective of people that published this paper because of the complexity that it gets into in terms of its thinking and what it proposes. Now, the title says Bitcoin, a peer-to-peer electronic cash system, which goes towards the whole concept that, it's about finance. But really, what I think is a better way to look at this is that it was a blueprint of how to build a world computer. Because since then, people have been taking this concept and running with it and turning it into different things that do more than just keep track of a value. A lot of them do that as well. They just keep track of a value, and that would be a different cryptocurrency. But they're becoming more complex to the point that they're able to keep track of more information, more complex things. And so what's important to think about this is that they all share one kind of underlying commonality, and that is the way that they store and handle data. More specifically, data that represents value. Now, value, in today's language has a specific meaning, connotation and kind of understanding. But what I think we will start to see going, forward is that our definition of value is going to change dramatically. And specifically our relationship with value. Now, in the top left corner, you see this blue dot that says UX. UX stands for user experience, and that's a field that I've been working in for about a decade now, geez. And my personal background is in something called human factors and applied cognitive psychology. Basically, it's a study of how people think as they interact with technology. And so what I do for a living is I work with companies to study how their end users interact with their technology to help them develop better user experiences, make it easier for people to accomplish things. And so I'm going to talk about this from that UX perspective. And so think about the user experience with value, how we interact with value. And that's going to change with world computers, specifically when it comes to like our perception of it, our expectations of it, our interactions with it, and our accountability for it. Now, think about content. Over the past 10, 20 years, the internet has drastically changed the way that we interact with content, our relationship with content. If you think back 10, 20 years, I don't know how old you are, whoever is listening to this. But personally, I could never imagine the way that we interact with content today with social media and Instagram and stuff like that. The internet, as we know it, has completely changed the way that we interact with content and our relationship with content. And what I'm trying to say here is that world computers will change the way that we interact with value, will change our relationship with value the same way the internet did how we interact with content. So that just kind of keep that in mind from a user experience standpoint. So the best way to kind of think of how these things work together to create a world computer, it can be explained with an analogy, again, that I've been kind of working on over the past couple of years. And hopefully this is one that you can use to help explain what's going on to people that you know during holidays, explain to grandma or grandpa like what's going on in a way that they're able to kind of wrap their heads around. And so we're going to dive into an analogy here. Imagine people from all over the world coming together and standing around a circular tarp or a parachute. Many of you may have done this in like elementary school where all the kids come out and grab a circular parachute and they pick it up and they wave it around and stuff. But imagine people from all over the world, and we're being kind of figurative here, meaning that these people, like though when around a tarp, are in physical proximity to one another. This analogy reflects people all over the world that are not necessarily in physical proximity to one another. So what we'll say is that we have Raja from Russia, Sven from Sweden, Bella from Belgium, Saeed from Saudi Arabia, Nasha from Nigeria, Indra from India, and Maria from Mexico. People from all over the world. And when they come together and stand around this circular tarp parachute, and they pick it up, it becomes taut, like a platform. It wouldn't be able to become taut like a platform if they all weren't there to support it. That's important to remember as we go forward. Now, because it's taut like a platform, it allows things to be placed upon it. For example, a red ball. Now, the people holding onto this tarp are going to play a game, or they kind of have instructions, and that basically involves them keeping track of all of the information that exists on this tarp, all the activity, all the information that exists on this tarp. And they do so by following a very specific protocol. And it kind of goes like this. One of the people holding the tarp is chosen at random to identify what they see on the tarp. In this case, we'll say that Raja gets to go first, and he says, hey, everybody, I see that there is a red ball on the tarp. The next thing that happens is that everybody else around the tarp has to come to an agreement with whether or not they think that Raja, has said the correct thing. And so in this case, we'll say that, Bella and Nasha and Maria and Sven and Indra all say, yeah, we agree there is a red ball on this tarp. Oh, excuse me, and Saeed. Forgot about Saeed. Sorry, Saeed. Everyone comes to an agreement that there's a red ball on the tarp, at which point a picture gets taken of that tarp. So imagine like a Polaroid camera sitting above the tarp that takes a photo, and it spits out copies for everybody. Everybody gets their own copy of that photo that documents the agreed upon status of the tarp. Now, I'm going to go back a second because something else happened as I was talking that's important, and that is Raja, being the one that went first and having everybody agree with him, gets a reward which gets added to the tarp. And as I said earlier, the kind of job or responsibility of the game that everyone's playing is holding onto this tarp is that they have to keep track of all that information. And so this starts the cycle again. Someone gets chosen to go first. This time we'll say it's Bella. And Bella says, hey, I see that the tarp contains a red ball and a yellow ball. And by the way, my prior records indicate that there was just a red ball before that. The same thing happens again. People around the tarp all say whether or not they agree with Bella. So Maria, agrees, Nasha agrees, Sven agrees, Indra agrees, Raja agrees, and Saeed agrees. At which point, a photo gets taken of the tarp, everyone gets a copy for their records, and Bella gets a reward, which also gets added to the tarp. So what does this kind of allow for? It allows for anybody to be able to roll up to the tarp and participate in this game of identification and reward. So we could say that Chad from Canada rolls up to the tarp and holds on to it. And as long as Chad is able to get a copy of everyone's records, he is able to participate in this. So let's say that Chad gets chosen to go first. He would say, hey, I see that there's a blue ball and a red ball and a yellow ball. And by the way, my prior records indicate that before this, there was just a red ball and a yellow ball. And before that, there was a red ball. If everyone else agrees, a photo gets taken, everyone gets a copy for their records, Chad gets a reward, which gets added to the tarp. Now you've noticed that these records are getting stacked on top of each other in chronological order, kind of like this never-ending photo strip that comes out of like a photo booth. You just keep taking a photo and they just keep getting linked onto the previous one, and it just keeps growing and growing and growing. Now, let's say that, well, let's go back a second here and say that Chad rolls up, but this time he has brought with him an incorrect copy of the previous records. And he gets chosen to go first. He could say, hey, I see that there's a blue ball, a red ball, and a yellow ball. And by the way, my prior records indicate that before this, there was just 3 yellow balls. And then before that, there were 3 red balls. as everyone around the TARP, goes to provide their, their input in terms of whether or not they agree, they would say, yeah, we see that there's a blue ball and a red ball and a yellow ball, but by the way, our prior records do not match yours, Chad. Therefore, a photo would not get taken of the TARP. Chad would not get a reward, and everyone's going to be real sketched out about Chad. Like, what are you doing rolling up with these false records, dude? So what have we learned so far? People plus a TARP equals a platform. Everyone must agree on TARP activity. All activity is documented chronologically, and new records are added to the top of the old. Everyone holds their own copy of all the records, and anyone can participate with their own copy. Participation is incentivized by rewards, but bad behavior equals no reward. So let's step this analogy up a little bit. So everyone's still around the TARP, they're holding on, but now we're going to introduce pockets, like little kind of pouches on the TARP. And in these pouches, people can hold their particular or their personal red balls. And so the same kind of protocol exists here. Their job is to keep track of everything that goes on in terms of the activity and what's going on the TARP. And so they follow the same protocol, and that goes like this. Someone gets chosen to go first. In this case, will be Nasha. And Nasha says, hey, I identify that I have 2 red balls. Indra has 3. Maria has 2. Raja has 2. Sven has 3. Bella has 1. And Saeed has 2. If everyone else agrees, then what happens? A photo gets taken of the TARP. Everyone gets a copy for their records. And Nasha gets a reward for being able to go first, which gets added to her pocket. And this starts the cycle again. However, we're going to introduce a little bit more complexity to it. Transactions, exchanges, right? So here we'll say that Nasha has sent a red ball to Bella across the TARP. Sven has sent one to Saeed. Indra has sent one to Raja. And so the same protocol exists here, but they're keeping track of a little bit more information. So we'll say that Sven gets to go first, and he says, hey, I see that these transactions occurred, these exchanges occurred between these people, which resulted in this particular kind of status of the TARP, these people having this many red balls. And by the way, my prior records indicate X, Y, and Z about the status. So if everyone else agrees with that, then the same thing happens. A photo gets taken of the TARP, everyone gets a copy for their records, and then gets a reward. So this cycle of activity, agreement, documentation, and reward just keeps happening over and over and over and over again. And as you probably kind of guessed this point, the red balls represent cryptocurrency, these pockets represent wallets, the TARP represents a decentralized ledger, the people represent a peer-to-peer network, and this ever-growing strip of photo records represents blockchain. So what we have to do real quick is kind of swap out the people for computers, because really what's going on is like you have computers that are existing in a peer-to-peer network. So instead of people coming together and using their arms to hold up the TARP, it's really computers all over the world coming together and connecting into a peer-to-peer network, which allows this decentralized ledger to exist amongst them. So the decentralized ledger isn't something physical per se. It's not something that you can actually touch and feel. But for this kind of analogy, it's easiest to convey it as such. It just exists because they are all there. Kind of like the TARP as a platform only exists because people are there to pick it up and hold it. Without these nodes, this decentralized ledger wouldn't exist. So cryptocurrency gets stored in wallets. Wallets are kept track of by a decentralized ledger. The decentralized ledger is supported by a peer-to-peer network, and the nodes in that peer-to-peer network leverage blockchain as a means to keep track of all the activity that occurs on the decentralized ledger, right, in this kind of chronological way. So everyone's got their own records, and in order to participate, you have to have the same records as everybody else. And in exchange for doing this, and this is important, like why would computers be doing this? Why would anybody allow their computer to go dedicate resources to this? Is that the incentivizing mechanism is to earn more cryptocurrency. Now, people are able to interact with this. People can kind of come up and interact with this system. And they use wallets. And this term wallet, I bring up the UX dot again because from a design standpoint, um, I'm talking about wallet applications, applications that you can download on your phone, download to your computer that allow you to interact with the cryptocurrency that exists on this decentralized ledger. It acts like a window, right, that allows you to kind of access it. But in order to access it, and real quick before I go on, these red boxes represent um, interfaces, like people standing behind a screen. Just to clarify, if you're wondering what these red boxes are representing, they represent applications, wild applications that people are interacting with, whether they're on their phone or a tablet or a computer or such. But to interact with the cryptocurrency through these wild applications, they have to have what's called a private key. And the private key matches a corresponding public key that is assigned to their given wallet. So let's talk about this real quickly. Why is it important to understand this nuance here, this specific detail? In a centralized system, as we discussed at the beginning, the way that you interact with that cloud is through login credentials. So I could have my email address, jeff@chockablock.io, and I could have a password. This is not my actual password, but we're just using it, for demonstration purposes. I have these login credentials. So does the cloud or the server. It contains that information. And when I want to access my stuff, I log in using these credentials, and the cloud says, yes, that matches what we have, and you can now interact with the content that we have, that reflects you, that pertains to you. But it also has a lot of other information about you, right? And you don't have it, it has it. Private keys and public keys take away the need for another centralized entity here. It's part of it. It takes away the need for a centralized entity to keep track of your personal information. So instead of you having login credentials that reflect you and the cloud or server having that information as well, instead what you have are alphanumeric strings that are cryptographically tied to one another. They don't reflect you as an individual, but they are tied to one another cryptographically. Think of this kind of like a safety deposit box at the bank. You get your own key, but the bank manager also has a key. And when you come together, you're able to put both your keys into the box, and it allows you to access the contents inside. However, this comes with some caveats, right? This is an important thing, especially to understand from a user experience standpoint. And that is, if you lose your private key, you are effed. You don't get a way to recover that. It's not stored like your passwords and your email addresses and everything are stored in the cloud. It is cryptographically tied to this public key. You and you alone are in charge of that private key. And so this is where I introduce this concept of what I call user accountability design. And what I mean by that is we are so used to, in the UX field, something called user-centered design. And that is like you design everything to cater to the user, right? And making sure that they can basically recover from the errors that they might encounter due to their own human faults. We are human, we have faults, we forget things, we lose things, and therefore it has been a big kind of thing that has occurred over the past several decades, that as we design interfaces and stuff, we make it so that people can't they can recover from errors, right? I talk about user accountability design in that in this particular system right now, it doesn't mean that it won't change over time, but right now it doesn't allow for that kind of forgiveness. And so as you design things, you have to be very specific with users about, look, this is your private key. You can't lose it. You've got to do X, Y, and Z with it. Write it down, laminate it, put it in a safe, make a copy and bury it underground. Like, do not lose it and do not share it with anybody. Because if they have access to it, they can walk into the bank and stick it into the safety deposit box. The bank manager doesn't really know, who really owns the key. So he'll go ahead, or she, or they, will put the key in and allow them to access the contents, right? So you can't lose that private key. That's basically what I mean by user accountability design, is like we've got to make sure that as we design things from a user experience standpoint, that we make sure people understand the burden of having custody of that key. All right, so I've digressed a little bit. Let me get back to the analogy or the explanation. All right, so now that you understand private keys and public keys, what this allows people to do is access the contents of their wallet, right? And therefore they can then do things like transactions. Again, we're dealing with the first world computers ever. What they're allowing people to do is simple. You can move value around. You know, think about the old video games out there. Like it was just like Pac-Man or something, like biting little dots. Like it wasn't complex. It was complex then, but it got real complex years and years and years later. You know, now we got virtual reality video games. It's like, my God, like you don't even know that you're actually in a virtual experience. My point again is that like, don't take the simplicity of what world computers can provide now as an indication of that they don't have a potential importance later on down the road. Anyways, so you can do transactions by using, you know, an application with a private key. Now, the way transaction works is that you use what is called a wallet address. And the wallet address, like the private key, is cryptographically tied to that public key. And so you use it kind of like a mailing address. So when you want to send funds to someone, you would put into your wallet interface their wallet address and then send the funds to them. Now, I'm going to go back a second because something happened there that I want to reflect on, and that is when you send that transaction, you have to pay a small network fee. And we're going to put that up in the top right corner as we move forward and just kind of bring it back in a few moments. Just kind of put it on the periphery there. So while all these kind of transactions are happening, the computers are in the background humming along, doing what we described earlier with that analogy of the tarp. They are keeping track of everything that occurs on the tarp by one of them getting chosen to go first. And instead of saying, hey, I see X, Y, and Z like a human does, it goes beep, bop, boop, like a computer says it in binary, because it's just computers following a computer programming language. And if all the computers agree with what that one computer says, then what happens? They come to consensus. That's what this is called, is coming to consensus. But if they all come to consensus, then that figurative photo gets taken of the tarp and it gets added to the top of their blockchain file, right? So every computer that is supporting this tarp has its own copy of the blockchain that is for that system. And when everyone comes to consensus, they add a new block to the top of that blockchain. Further, the computer that went first gets a reward in the form of more cryptocurrency. They also get the network fees that went along with the transactions that they helped solidify into the blockchain that every node has a copy of. Now, there are nuances that exist from one blockchain system to another about how this works, but for the most part, that's a good way of thinking about it. The computer that gets to go first gets a reward, and they also can get the network fees. Now, this happens, this consensus happens at different intervals of time for different world computers. For Bitcoin, it happens approximately every 10 minutes. And it is designed in the programming of the protocol that all the computers are following to make it always about 10 minutes in time. I'm not going to get into the details of how that happens in this video, but I will explain it in some of my additional videos. But some systems follow a different kind of time schedule, or block time, right? It might be faster in terms of how frequently computers come to consensus and therefore make a hard, record of what has happened. All right, so why is this disruptive? Again, I keep harping on the idea that like, oh, this seems kind of trivial, like you just are able to keep track of a value. But the reality is, even if this is the first thing that a world computer does, and again, looking at the trajectory of what happened to computers and assuming that the same thing could happen to world computers, meaning that they're going to get more powerful. Even then, looking at it now, why is this disruptive? Well, people that live in cultures or regions of the world that have certain degrees of infrastructure, specifically when it comes to banking, they already have an infrastructure that keeps track of value, right? You put value in a bank and it keeps track of that value for you. And we have things like Venmo and PayPal and Cash App and all these ways of transferring funds between us. But when we think about what really goes into that, it's actually quite a lot of infrastructure. So let's say that I bank with Bank X and I want to send money to somebody who banks with Bank Z. We both have Venmo and we use Venmo. I use Venmo to send money to that person. And it seems really seamless, but really what's going on is that you have the Venmo application, which requires a team of people to build and keep up. And that application, the people there that are building that application have to stay on top of all the banks out there, their APIs, and those things change. And APIs are basically ways for different applications to share information from one another. And so every bank out there is going to have its own proprietary software that they use to keep track of all their accounting, who has what. That stuff is built for that particular bank. Think of all of the banks in physical form, all the buildings. Think about all the people that have to work there to build that software, to act as tellers, to act as people that support that entity in some way. That's a lot of infrastructure, and that's why you pay such heavy fees to move money, because they have to support each other. It's also why it takes a long time for transfers to happen when you do one from one bank to another. Like, it can take a couple days before it actually goes through, and it's because you have all this infrastructure in place that it kind of has to go through these different hurdles, and you have to pay fees so that the banks, basically they're providing the service for you by keeping track of this value, and that's why you pay those fees. But think of regions of the world where that infrastructure doesn't exist, and there are lots of those, where they don't have the same kind of banking infrastructure that a lot of us are very fortunate to have. And therefore, it's very hard for them to send value from one person to another. So imagine if, instead of having to build all the infrastructure that a lot of us have grown to take for granted, they just have to tap into a world computer that keeps track of it all for them. And that's why this is disruptive, simply from a financial standpoint, is that all of a sudden you have an entity that runs on its own, that doesn't need any kind of corporate control, doesn't need any kind of government control. People put their computers up to keep it running because it is incentivizes them to do so by earning more cryptocurrency, and people can use it to keep track of things. Again, Bitcoin, the world computer that does Bitcoin, only really keeps track of who has Bitcoin, who's earned what Bitcoin, where is Bitcoin. But again, as these things get more complex and are aimed to do other things, you can have world computers that keep track of other kinds of value. And I'll talk about that, in additional videos to this. But for now, just kind of keep that in mind. All of a sudden that you have a world computer that's decentralized, it is immutable, it is irrepressible, it is trustless, meaning that you don't have to worry about it fudging the numbers, and it will keep track of value for anybody that uses it. That's why this is disruptive. So at this point, you should hopefully have a better understanding of what cryptocurrency is, in terms of how it's stored in wallets, and what a decentralized ledger is, and how the peer-to-peer network works together to keep track of everything, and how blockchain really is nothing more than a way to keep track of information in a chronological way. But when used in combination with all of these other things, you get a world computer, right? Something that is decentralized and financially self-sufficient, and all the other things that I was talking about earlier. And more often than not, we simply refer to this as blockchain. When people talk about blockchain, they more than likely are talking about this from, they're using that term to reflect the larger interworkings of these things that we just discussed. Not all the time, but for the most part. And there are different kinds of blockchain systems out there, but I'll talk about that in an additional video. But I hope this was helpful, and I hope that you're able to take this and be able to explain what's going on to other people out there, because I think it's interesting, and people should know about kind of what's going on in the tech world when it comes to this new and emerging technology. All right, take care, guys.